Hello, welcome to this video. I thought I would go through some of the changes that I've done with my project Odin's, which we can probably see. Uh, what is it? It's Odin's, and this will work. Right, so Odin's is interpreter I'm making using the Odin programming language, and I'm implementing a Z machine virtual machine. So the aim of this is to be able to run what other emulators might be able to do, which is run Zork and like you can go north and whatever, and you can basically play the game. So there were a few tools which I need to set up by going to what are we? Maybe I want it the other way around. I'm not too sure. Doing keyboard things as you do. So I think I want fingers in the right position, and where are we? We're there, we're source, we're third party with these tools, and I think it's just in there. And so that gives us, there was a meaning for that madness. That gives us some decompiler tools just to see what's happening. So that's what that does. And it also gives, what was it? We can find out. Source third party Z tools. It was info dump. So if we go info dump, that same file gives a header. So we saw in the last episode that the header was basically working. And from there, I have actually gone a little bit crazy. I've basically done a bunch of the execute and instruction parsing because a lot of adding new opcodes is like just really tiring work to do on camera. I found I could just work so much quicker just in the lounge. So I have done a bunch. So we can see what it looks like if we do that. And so this goes a fair way. Let's just scroll up to the top. So what it's done is it's loaded the ROM file. It's worked out from the header where it should start. So it started at this location. It was able to decode this series of bytes into this instruction. So call that address with these arguments, and I'm going to save the return value to the stack pointer. And you can see here it like does actually call kinda. So when you call something, there's a bunch of bytes saying these are the initial values. Well, actually, a bunch of words starting with a byte saying how many words there will be. And that's to say how many local variables there are and what their initial value is, which is usually just zero, and different versions do different things. So we can kind of see what I was just talking about here. So header includes 1 byte, number of local variables, and then version 1 to 4 has the initial values, so that number of 2 byte words. And version 5 and later, there's nothing, but I'm only kind of looking at version 3 at the moment. But some of these like kind of small version specific things I can kind of go and look into. And if people are interested, the Z tools is available here. Just try and reload that. Um, might not be able to open that in this browser. We'll look at that a bit later. Does that mean this won't even load? Yeah, I wonder what that issue is. Is it like, oh, it might only be HTTP, in which case I'll have to update these links in my README. Good dog fooding to test that. But so this is ZTools, and it has like executables for a bunch of old systems that probably no one's running now. And also the source code, which you just make and then it's done. So yeah, that's calling routines, and also had to deal with instruction decoding, which is probably the more complex type. So I'll take you through the code and kind of show what's what. And I believe the next step in my journey is actually, well, yeah, we can kind of see it. Because it failed at not yet implemented at put prop. And what it's going to do is it's going to find the object in RAM. So we're going to have to implement object parsing and how that goes. And the TXT, if we look at TXT and like grep with prop, you can see here that it sometimes writes a string rather than a local or global variable, and I assume there's none with stack pointer, but I assume it's an option, and I'll allow it to be an option. So here we need to basically implement strings as well, and strings are just another kettle of fish. So there's this kind of not ASCII but SCSI, but not like the SCSI hard drives and whatnot back in the day. So it's kind of interesting. Each character is just 5 bytes, so you can actually fit 3 characters into one word with like one bit kind of saying what's what. And then each of those bytes can do certain things, and it's got different layers, which I actually appreciate now that I've had it for a while, but I've got a keyboard that can do multiple layers depending on how I do. I'm playing around with some of my layers at the moment, which is why you might see weird typos and but yeah, so basically you've got different layers and you can switch between them with certain Z characters. And you also have like abbreviations, which is like a whole another thing. And escape codes, and you have just the main alphabet that you can kind of write. And you can see here the first layer is lowercase, the second layer is uppercase, and third layer is symbols. So because of the reduced alphabet in each layer, each character doesn't actually have to take up much space, which is why it's only 5 bytes. And there's like a bunch of rules on like truncation, what is it, padding and truncation, and a whole bunch of stuff. And there's also stuff that is only really implemented in higher versions, like having mouse clicks and whatnot. So I'll probably start writing this kind of with stubs, how I've done, and just leave like a call to unimplemented, so it crashes like it did here. And it will print out a message not yet implemented. So that is strings. So we might be coming to that today, and I think we probably will. But the first thing I want to do is actually it'll be, yeah, object table. I want to actually be able to read an object, which is another weird thing. And then I will be able to uh, kind of read this text that it's got. So Yeah, basically get that text so I can then print out the instruction. The way I'm doing it is I'm basically implementing the uh, dumping of an instruction, so the printing out, before I implement the actual execution part. But that's that. So there's also like um, instructions encoding, which is kind of a bit strange. I kind of didn't really talk about it. I said it's just something, but basically you have to read a certain number of bytes depending on a lot of various things. And this page is like not really laid out that well. There's some hints from the author that's kind of annotated it, but it's you kind of have to keep jumping back and forth. Anyway, enough talking. What I might do is open up things and see what it is. So we looked at header. Header hasn't really changed. So we'll get rid of that. Instruction dump is new. An instruction is new. Have to like hold keys for a certain amount of time. So machine I've added a bit. So we were kind of execute and we didn't really have anything. So I put in like a basic endless loop. So in Odin, you just do for with no conditions. And you can see here, like, you basically have, you parse the um, instruction. So there's another method that we'll drill into. Um, and it's kind of printed out. And the instruction, when it parses itself, it will work out how long it is. So then you have to like offset the program counter to be there. So the next instruction can be read on the next try, depending if there's some opcodes that will kind of need to change it again. So some opcodes are reasonably simple. Add does some stuff. Notably, it actually does signed addition, even though everything's stored in unsigned, which is why we've got the I16 and U16 to do weird things like that. But that's what happens when you do emulators. And call has a new thing, packed address. So we'll just dive into that. That's quite simple. And then it basically starts it reads a routine, which is what is going to be called, and then that routine kind of creates a stack frame, and then we append that to the current frames. And I put like a little thing here. In fact, I probably do like has Z is that? Yeah, has Z string. I should probably do something like that as well. Um, so yeah, and then you have jumps, which might do some things. So it first has to test a condition, then test whether the condition is what the jump needs to do, and then depending on the offset, you either just return true or you move the program counter again. And I probably can do that R true and R false, but I'll probably just hit it when I hit it. Jump just jumps normally. Load word basically loads a word. Well, it loads a word from a certain index and then stores it into what it needs to store in. Put prop is unimplemented, but we'll do it. And you can kind of see that each of these little chunks are reasonably small. They just do what they need to do. And I made some procedures to read and write operands and read words and write words, which is up here. And it's basically just some bit mathematics. So we looked at the header, the byte, and the word. So the word just takes it, shifts it, gets the next one done. Except that should no, go back to weird keyboard issues. Need to make sure I'm out of that, and then I want to do that. Make sure we only get the next one. Oh, wonder if that's been causing issues. I haven't noticed it. The right word surely does the right thing. And most of the time for the instructions, we're just reading bytes. But yeah, we'll see how it is. And yeah, so there is actually quite a bunch of stuff that I've done. So like all these reading and writings. And the packed address, basically, depending on which version, you do certain stuff. Version 6 and 7, they have like an extra field in the header that you have to get, depending on whether you're a routine or a string, but not really targeting that at the moment. I'd have to pass in a new method for that. And yeah, this routine read, that's basically doing the thing that I was talking about before. You read a byte, that's how many variables there are. If you're less than version 4, well, if you're version 1 to 4, then you, for that many variables, you read a word. And I do want that changed. And this file here hasn't changed at all, so we'll just close that. And instruction dump we're going to talk about. Now instruction, so instruction has like quite a complex thing. I don't know why they make it so complex. Basically, when you read an instruction, you read one byte. You always need to read one byte. And then if certain bits are in certain places, so they kind of mention it here. The pictures here are not normally broken. This is me just using a different browser, and I think if I use something like Firefox, it looks fine. Yeah, so it looks fine in this. That's just because I'm using a different browser. This is Ladybird, which is a new upcoming browser, written entirely from scratch, not depending on anything. Well, it does depend on stuff, but it's not like using existing renderers and whatnot. So cool project. Thought I'd follow it. It's kind of usable. But yeah, anyway, so if certain bits, well, the top two bits are in certain forms, then it's basically parsed differently. And so because of that, I have the various forms. So we have read variable, read short, and read long, and also instruction extended if it's a certain byte. But in this case, that's usually only on later versions, I believe, from reading. So I probably won't actually hit that in my thing. And then after all of that, you have to read. Well, these will read the operands depending on what types and how many bytes they need to read. And then you have to read any store bytes and any branch bytes and any Z string bytes, depending on what opcode it is. So this part will parse the opcode and the operands. So if we look into one, the long mode, opcode number is the bottom 5 bits, so we can see here we get 5 bits, and we do kind of a check, bounds check, and then print out. We don't know about this opcode, which is a good thing to do. And one thing I was thinking of doing was actually doing to just doing that, and I'll do it in other places as well. Because if it's earlier in the array, it might be unknown, in which case we check for it here. But if it's after the length of the array so far, it will crash. And so before it crashes, I want to crash showing which line it is. But anyway, in long mode, depending on which bits are set, so I've got a little helper method bit, which will tell me if that bit is set. Then we need to read certain operands as either variable, small constant, variable, or small constant. And that's for the bytes that it will kind of advance itself. And I want to go here. Don't usually use the mouse for Vim, but I've got my hand on it. It's actually a trackball. Well, yeah, a trackball. And anyway, enough about mice. It's also got a short form, which is a slightly smaller opcode number, and the operand type uses up 2 bytes, similar to long mode, and that does certain things. So you kind of do that, and yeah, I haven't implemented it when it's just 0 AP. It's probably quite simple, and they'll probably get hit. It's kind of a good thing to do to have lots of parts of your code that will crash in the place that it's broken. So I might have something like unimplemented or unreachable, meaning I think it shouldn't ever get there. I have asserts in the main engine, so that's kind of checking that the state is in the right state that you're expecting. And they're kind of useful mainly during the debugging part, because it will help you work out what you need to implement next. For production, maybe have it off with a flag, but that just adds kind of more code. Anyhow, the variable length instruction is a bit longer because it does some other stuff. So that's kind of the 3 ones that I've implemented, but I haven't actually implemented all of them. And go there and here. Also using the wrong hand for the keyboard. And so because of all that, I have help methods to read the operands, and it does certain things. Basically, it reads a byte, and if it's a large constant, it reads another byte. Either way, it will just add that to the operands list. I haven't done Z-string. And here I was saying before, so like instruction F1, but that's just the helper methods. Read store will basically read the other byte if it needs to, but you don't know if it needs to until you get the opcode. So here you have basically a list of opcodes that don't need it and a list that do need it. And if it's unknown, that should be unreachable, because I should have caught that earlier in the code. So that's kind of a good bounds check, I guess. And then if it decided it did, it reads the next byte. Similar with the branch, list of things that need it and don't. And if it does need a branch, it will do something slightly different, because if a bit is set, then it will get another byte and kind of join it together. And they're kind of like signed if it's in this part, but not signed if it's in this part. Oh, yeah, it's interesting. But it seems to work, and once I get it a bit more working, I'll probably do more of a stress test. I think I want to just add what I've done there to those. Might do that separate. Ah, no, I'll just do it now. Small fixes. It's not really the best message, but it is what it is. So that was a quick rundown on the instructions. So I also have instruction dumping, which is potentially harder. So it does like certain things. It can dump the operand, just an individual operand, in which case it'll do stuff like that. Or it can take a slice of operands, and then it'll basically throw a comma in between. The actual instruction when you're dumping it, it'll do like a bunch of stuff. So it'll say where it starts, and then it will show each of the bytes. And if there's an indent, then we'll like do the indent if we're splitting to the next line. Otherwise, we'll just put spaces, and that kind of it makes it look very similar to the TXT, which is kind of what I'm looking for because it's a handy output. And here we have opcodes to string, and if it doesn't have an opcode, we just put question mark. Hasn't come up yet. And then for each opcode, we have to work out what we want to do. A lot just you can dump the operands as is. If it's a call, then it will do something slightly different because it needs this packed address. And then I'll put like brackets around it. If it's a jump, then it does certain things on each of the things, and it helpfully works out what the address should be. Put prop haven't done yet, and if it's got something to store, it'll show that with an arrow. And if it's got something, if it's branching on something, it will say whether it branches on true or false, and then it will show where it will branch to. And the Z string haven't implemented yet. And I realize I didn't actually show all the opcodes. So we've got all these opcodes at the moment, and here are the arrays showing what types they are. And we can get that from instruction set. So the table of opcodes, we can see there's a bunch for 2-op, there's a bunch for 1-op, there's a bunch for 0-op, and a bunch for variable op, and there's also extended op. And so here I basically put which numbers each one should be. The compiler should yell at me if I put two numbers the same, and the question mark means it will just work out how big it is. And because I put unknown as the first enum, that will be the default option if you try and get something in between. So yeah, that's kind of that. So I guess I wanted to do this and kind of just do this. This crashed earlier. I did make that one change. But I kind of just want to see what it thinks is happening. Here there were txd see open. Yeah, I wonder here. Come on. That if we just go to less and what if we search for 5499? Yeah, so this is not going to the right place. We'll start at the scratch. 4F 05. I need to do a flag like -N or something. Yeah, they were probably all there. So that does 5472. So 5472. 5479, and that's equal to 5486. 5486. And that should start on 5491. Yep. And yeah, I wonder. So I guess it didn't jump because it's just doing this, and this is like a valid thing. So 2 ops 15. 2 ops 15 is a sub. So I guess yeah, I'll just do this one. So I think the change I made was in machine, I believe. And back, please. So this used to be 2, which I wonder if we do this. Yeah, then it's crashing on the prop. So this could be like slightly easier. It's kind of annoying. Not that one. Um, I'm pretty sure this should be right. So you're reading a word, so you want to get it at address and then one after address. So I think, well, I just had a bug in my code and now I'm going to this. Do we need to? Cool, that is good. So what I might do is get rid of this because it takes up precious space, and we'll get this to ops 15, which was sub, and I'll show you kind of process on how you do it. So you add sub in there, and what I might do is in this command I'll do a write, and then you can do that. And now Odin helpfully tells you there's unhandled cases in a bunch of places. So here we have to work out whether it needs a store operation. So how I did this was basically look at the dictionary and you go down to sub, you look at that, and it requires a store operation and 2 operands, but we don't need to care about that. So sub does indeed have it, and so far I'm keeping things alphabetical. So that's cool. go to the next one. And so what's this on? Instruction dumping. So when we want to dump the instructions, we kind of just want to print them. And in fact, we can have this and do that path and then ext, do that, search for this. And yeah, so it just does a comma in between. That's kind of what I thought it would. So in which case you can just use this helpful one. Because yeah, these other things do different things, and it does the store for me down there. So if we look at this one, I think I want to go maybe like that, then that, then that. No. Um, maybe that, then that, 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 then that, then that. No. Yeah, that's probably what I want. So does it need a branch? It does not. So we will go over here and dot. Need that. Gosh, new keyboards are weird. Doesn't need this, so can't do the same. Do that. I think I need to change my keyboard to not do this. Now, what I might do is copy add. So this is the execution of it. So here we can see what it needs to do. Sub is signed 16-bit subtraction, which I believe is A minus B. So we get A here. We want it to be signed. So what we'll do is just change this to minus, and change this to sub. Yeah, I think that's kind of how it should go. Cool. So now if we do this again, did we not add it? We didn't do the most important part. Do that. Do that. Cool. So it did the sub, and now we're going into the next one, which is jump 0, most likely. I won't be there. So 1-ups 0. If we look back at this page, 1-ups 0, jump 0. Ha! Look at that. So I guess that kind of shows how like mundane it is adding operations. But how you do it is you do just kind of go through and add them one by one. When something doesn't exist, you add it. When something doesn't exist, you add it. When you spot bugs, you spot bugs. So yeah, that was an interesting bug. the reading like 1 1, it basically caused a branch not to happen or two to happen. Well, not to happen, it just fell through. Whereas before it was branching and then doing stuff, then returning, then doing that put to prop, which it will eventually. And I've got the unimplemented bits to go with it. But for now, we just soldier on and do this. And it reckons it's there. So jump 0. We do have a link. JB up here somewhere. That did like not jump. Right here. So jump if a equals 0. Keep that in mind for when doing it. So, does a jump have a store? No, it does not. Jump 0. Come on. Printing out the instructions, it can just do the same. That's right, jump is also a weird one. It doesn't have a branch doesn't have a branch part of the instruction. It just has a parameter, which you can probably see just here. Not a branch instruction, so it's different. Right, do we need a branch? Yes, we do. My shift key is where S is on this keyboard layout, and so sometimes it's basically if I hold shift, it becomes a shift key, but if I just tap it, then it's an S key, which is substitute. So he'll just go and basically delete that character, then go into insert mode, which it's frustrating, but we'll do jump 0, and go on to the next one. So this is actually jump 0. So case let's see video. That was the wrong command. Jump 0. My control and alt and whatnot in similar places. So I'll put this just here, but I think what I'll do is kind of steal that. Well, actually, I'll it just goes to it, I guess. So yeah, it's only got one instruction. here's a branch, and condition is going to be a equal to there, and don't need to do that. We did like a little print. Yeah, so I'm just thinking some of this, it's basically the same as the other jump instructions, but not jump. But I think there's only like, oh, no, there's a few. There's like jump equal, have a jump. So I think what I might do is refactor this out to basically have a jump condition, and then at the bottom, if it's got a branch and the condition equals the branch condition, then do the thing. But for now, I'll just copy paste, and that would basically free up. All of this would just disappear, and that would kind of keep things in line with their kind of nice small little things. But for now, let's run this again and look at that. It fails in the put prop. I trust it. Don't know how much I trust it, but once we get text kind of printing out, and it will start showing whether it's kind of working or not reasonably quickly, I would think. So I think at this stage, didn't do what I was intending to on this video because found a bug, who knew, and ended up just implementing a couple. Yeah, ended up implementing two different instructions, which do various things, and because of that, I think that's probably enough for this video, and maybe next video I'll either walk through parsing the object or just show you the code, how it's done. And yeah, the source code is available here, and I will push this stuff once I get it all committed up. I mean, I can just get monkey live commits, nothing can break. Yeah, I might do just some general refactoring. Add sub and JZ. Always like adding JZ. And yeah, let's just push. It'll ask me a thing, and I'll be like, yep, all done. So we can see that is live now. Oh, there was that thing. Well, I'm dubious. Yeah, like it works here, so I think that that's just a bug with yeah, it's just a bug with Ladybug, I think. But yeah, we are making progress. I'm happy with that. So it is now doing pretty much the same as it was before, but maybe more accurately. I could do something like show the machine state after each thing. What I kind of want in the end is to have multiple panes, I guess. So you have one pane that shows just the instructions going past, and then one pane that shows the input and output. Because eventually it will get kind of weird when we're like writing into a terminal that's also splitting out. But the splitting into panes is like a different issue to what I'm trying to solve here, so I'll probably end up doing that outside of these videos, but it might become apparent that there's multiple panes doing multiple things. And when that happens, it will be a lot easier to kind of show the machine state as you're going. And you might be able to single step through each instruction. And all these things will kind of just help debug, I guess, because you'll probably run into issues just anytime you're writing an interpreter. So that's just how it is. But I guess that's all for now. If you're liking this project, feel free to try it out and let me know what you think. And for now, thanks, and I'll see you next time.